So we've looked at the comparison between ideal science and real science, and we've looked at how we can better understand those questionable research practices. And I've tried to show you that by going back to, well, what are we trying to do in the first place? What is the meaning of the p-value, and how can we use that in setting up our decision procedure, comparing the p-value to alpha and setting our power. And we've looked at what goes wrong when we do research in a certain way. And what that shows is that we need a different approach to research. Not necessarily not comparing p-values to alpha anymore, because that could be up for debate, right? And that's what we're going to debate at the end of the block, whether we're better off being Bayesians. But it's also about the research process and the publication process, and the degree to which scientists themselves are willing to bend themselves backwards to prove themselves wrong, which is the final topic for today. So I think I mentioned this briefly. Mentioned it a couple of times actually. Is that the incentive structure in science is not ideal. So what is the best outcome for individual scientists is not necessarily the best outcome for science as a whole. So a summary would be that if it's indeed the case that whether or not you show significant results determines whether your results are getting published in a paper, and that publication, the amount of publications you get would make for a better resume and a better career, and would improve your chances of getting subsidized, getting more money for next research, and which improves your opportunities in the job market and your opportunities to pay your mortgage, right? Everybody has got to pay the bills, even researchers. Then that incentive structure is not right, because at the beginning, being able to show significant results is the basis of publications, is the basis of your career, is the basis of, paying your bills. So that is a skewed incentive structure, and we should align what is good for science more with what is good for the individual scientist. That means that we should focus more on the quality of research. Not necessarily is it significant or not, but has the study been conducted in a proper manner or not? Because we can't reasonably expect individual scientists, which are just another example of human beings in general, to be free from errors and be that ideal scientist that we want them to be. Because we're sensitive to different forms of error, different forms of bias, 4 of which are mentioned in the Nusso article. I'm going to briefly talk about them here before wrapping the lecture up with some general suggestions that have been made about how we can improve the situation. But we first start at the individual level. So we're going to start at the individual level of the researcher. What should they be on the lookout for? And then we're going to look at science in general. What could potentially change, or what is changing even. So the first type of error that scientists are sensitive to, or people in general, is hypothesis myopia, which you could say is a variation on the theme of confirmation bias, right? So we're looking for confirmation of our ideas, and we're more likely to check out things that could lead to confirmation of our desired hypotheses or viewpoints, not necessarily, we're not on the lookout to disconfirm our existing ideas. The example that they give that she gives in the publication is how does disgust influence moral condemnation? So you could test that by saying, well, people who have been exposed to clutter in a messy room, for example, or smells operationalized by using a fart spray, favor harsher punishments. So you have participants, you put them in a room, they're the experimental condition, so you put fart spray in a room. I didn't know it was an actual thing before this research, but apparently it's a thing, fart spray in a room. You put participants in there and you ask them, somebody has done such and such, should they be punished harshly or not? And you look at, well, yeah, they should be punished harshly, right? And perhaps people are more likely to say they should be punished harshly if they were exposed to the fart spray. Then I could conclude, yeah, look at that. My hypothesis had been confirmed. My theory turns out to be correct, because my theory is that moral condemnation is related to feelings of disgust. So if you feel disgusted by the fart spray, you're more likely to condemn something that somebody did. But what you should be on the lookout for as a critical thinker in general, but as a researcher in particular, is that what else could explain these same results, right? So what actually happens here, and this is a type of argument that you're going to recognize a lot when looking at the research articles that you're going to read this blog for the tutorials as well, is you could call it a black box argument. So what we know is outside of the black box, right? So we know that we put in fart spray in the room, and we know that people came out favoring harsher punishments. What we don't know is the process that would explain that result. Given the input of fart spray, what would explain that they favor a harsher punishment? Is it discussed? Is that the most likely explanation for what happened here? Maybe, but perhaps there are different explanations as well, and you should be on the lookout for them. So another way of looking at this is using that frequency tree or the decision tree that we talked about a lot. Is that, sure, what we need to know is, given that our theory is true, indeed disgust occurred, and that's why people would be more likely to offer moral condemnation, how likely is it that people would support harsher punishments? Is it highly likely, given that your theory is true? Fine. That's something that's useful to know. If my theory holds, this data is likely to occur. But you also need to know how likely it is given different assumptions. How likely would it be that people would give the same response? They would still support harsher punishments if your theory was false, but it's actually the case that people were just angry at being badly treated by the experimenter, right? You don't see this a lot in research, and we should see it more often, which is the first step to debias ourselves as researchers and not only be on the lookout for confirmation of our favored ideas, but also look for disconfirming evidence, or at least try to gauge how likely the same results would be given different assumptions. The same applies to the BEM article as well, right? So you put in stimuli from the future, so you're priming people after they decide something, and then you see that they select a specific curtain. What is in the black box? Is it precognition? Can people sense the future, or is it something else? I don't know, but you should at least consider it, right? So how likely is that deviation from chance that we saw to occur given that precognition exists? But how likely is it to occur even if precognition doesn't exist? Some other stuff is happening, right? So something went wrong in the experiment, or something of the setup of the random number generator was wrong, or whatever could lead to any deviation from chance, right? So you need to consider the opposite, basically. A cure for hypothesis myopia is thinking opposite. So if my theory is true, my assumptions were correct, how likely is this to happen? But also, if it isn't, how likely would this to occur as well? That's the first bias. The second bias is the Texas sharpshooter, which is a different way of saying that people get fooled by randomness. I called it normative neglect in earlier lectures, that people fail to account for the rules of probability in updating their beliefs. And that's what you see in those questionable research practices. That's everything we just talked about, right? And what I show you here is another quote from the actual BEM article, in which he actually basically describes dropping one of the conditions. So I actually started out having a neutral condition, an erotic picture condition, and a non-erotic picture condition. And somewhere along the way, he decided, well, the interesting stuff is happening with this variable, so I'll drop the rest and not even report it any further. But he was very open about it. But what you see is that what Ben didn't realize in writing down his results is that he was basically just capitalizing on chance, right? He was making it more likely that we would find a chance result. All right. And that's a general phenomenon, right? People show hindsight bias in their convictions. So if I were to ask you, or BEM, depicted here as a blue-headed person, before doing the research, how likely do you gauge it to be that people are able to be influenced by stuff from the future? Then you would say, well, not very likely. You would say it's less likely. I don't think it would happen, right? Null results would be very likely. And I wouldn't be willing to say that time-traveling porn, as it was called in the media when they published or reported about BEM's results, is real, is something that happens, right? People were only influenced by erotic pictures. So that's why they called it time-traveling porn. If I would ask you before the research, how likely is this? Then you would say it's not very likely. And your conviction that nothing is going on, depicted by this histogram of a tumbleweed, is stronger than your conviction that time-traveling porn is a thing. But if I were to ask you, after you've seen the results from the BEM study, so we're further ahead in time, what is more likely? What did you think going into this study was very likely? Then your more likely to overestimate the degree to which you were convinced that, your theory could be true before doing the experiment. Basically, what the hindsight bias means for researchers is that after we've done the study, it's very difficult to differentiate between what we could have expected before we started doing the study and what is influenced by the stuff we learned by doing the study. So it's very difficult to gauge what you could have predicted on the basis of your theory alone, or what's just influenced by what you actually happen to find in the data set. Because we have difficulty in gauging in hindsight how likely events were before they happened, people are more likely to engage in just so storytelling. They're more likely to capitalize on random stuff happening in their data and trying to explain that with a good story, which is just so storytelling, right? So we found something, it could be a fluke, but we paint a nice picture to make sure it fits the data. And people are more likely to do that because of that hindsight bias, right? So in hindsight, it's difficult to think back to how things looked before you saw the data. So it's difficult to gauge what could have been predicted on the basis of your theory alone. All right. That is something you need to bear in mind. So the combination of the Texas sharpshooter and just so storytelling, so the fact that people see random stuff happening and they overinterpret that random stuff happening by telling a just so story, is something that occurs in a lot of published research as well. So what you're going to do in your tutorial group is you're going to look at two different publications, one about the effect of warmth on the physical warmth, so holding a warm coffee mug, for example, has on your judgments of the character of other people or even your consumer choices. And the other research, the other half of students is going to read a paper about whether the color red and blue has a differential effect on, people's motivational state in completing different assignments. And what you should be on the lookout for is that garden of forking paths. So if you're looking at that publication, constantly ask yourself the question, well, the researchers did this, but what else could they have done, right? And what were the considerations in doing so? Perhaps that leads you to conclude something else than the researchers do. Perhaps that leads you to think, well, we should definitely try to replicate these effects before we try to explain them, right? Because it could have been just a fluke. But if we do 30 more of those studies and do that with a lot of participants, perhaps something else would happen. Perhaps nothing would happen. So be on the lookout for that when you're going to read these articles before you're going to make the presentation, and think back to this lecture and that garden of forking path that we talked about. By the way, on both studies, replication attempts have been made. So for your assignment, that would be a good tip. Make sure that you look those up, because in those replication studies, they actually point out the stuff that was unclear from the original study to justify the replication attempt. So that could help you with that assignment. All right, so we looked at the hypothesis myopia. We looked at the Texas sharpshooter fallacy and the just so storytelling from the Nusso article. And one of the causes that we're in this shitty situation is that it was actually encouraged for a long time in the training of young psychologists such as myself to engage in that just so storytelling. So a manual that was given to students a lot back in the day when I did my study, actually encouraged people to write down the results in the most beautiful light you could imagine. It says, if you see dim traces of interesting patterns, try to reorganize the data to bring them into bolder relief. If there are participants you don't like, or trials observers or interviewers who gave you an anonymous result, drop them temporarily. Go on a fishing expedition for something, anything interesting. No, this is not immoral, is what the guide told new scientists to do when they were doing their analysis. When writing down the research results, this guide actually encouraged the following in reporting finding. Alternatively, the data may be strong enough to justify recentering your article around the new findings and subordinating or even ignoring your original hypothesis. Think of your data set as a jewel. Your task is to cut it and polish it, to select the facets, to highlight and to craft the best setting for it. Many experienced authors write results sections first. That should look weird to you, this advice, after all the stuff we've talked about. What they're basically advising here is to, well, indeed make the most of random patterns and ignore the fact that you couldn't actually predict the stuff that happened in advance on the basis of your theory, and write down your report suggesting you could have predicted them and the stuff that happened wasn't a fluke but was a robust phenomenon. And there we have it. One of the causes beyond the incentive structure is that people thought this was the best way of going about doing research. And that's one of the things that we're trying to change with this course. Better informing students, better training students about the best way of going about doing research and writing down the results. And I hope at least this lecture paved the way for that effect. And perhaps it's also interesting to know who wrote this manual that a lot of psychology students got as part of their undergraduate in psychology. Undergraduate students got as their education in psychology. There you have it. It was called Writing the Empirical Journal article, written by Daryl Bem. Daryl Bem, you might remember from the stuff about the future influencing the past. So he actually wrote the manual on how to do research, and he used it, of course, in his own research as well, which is highly questionable, as I try to show you over the course of this lecture. Finally, one of the biases that we haven't talked about is asymmetric attention. So you're more likely to check stuff that you wouldn't expect on the basis of your prior assumption, and all the stuff that happens that is in line with your assumption. You're not, so you're only using your critical thinking glasses to check out all the unexpected stuff, and you're not using them to check out the expected stuff, which is actually in line with some of the stuff that we talked about in the first year, right? So we've seen some research results about motivated skepticism, one you might remember. So if you tell people that drinking a lot of coffee raises the risk for getting breast cancer, then women who are more susceptible to getting breast cancer are more likely to scrutinize those research results than men, who are less likely to be affected by that health hazard. What it basically, how that has been interpreted is as a form of motivated skepticism. People are more skeptical about stuff that could negatively impact their self-view. And that could apply to scientists as well, right? Not necessarily their health, but all the stuff that might have a negative consequence for their career indirectly through not being able to publish significant results. They will be more likely to scrutinize that than all the stuff and all the decisions that could lead to significant results, as made very explicit in the excerpt from the writing manual written by Daryl Bem. So, we're in a bit of a messy situation. You are in a bit of a messy situation as well, but you're in a better position than I was when doing my studies to improve things. So what should we look out for to improve things, right? So we're in a situation of non-replicable results and dubious research practices. So we should look out for that first, right? So are the frequentist statistics used in a proper way? So if alpha is set at a level of 0.05, is that level justified? And is that in line with the decisions the researcher actually made? Is the researcher transparent enough about the research that she did to actually gauge whether that alpha level corresponds with the implied type 1 error probability? We should emphasize correct design, execution of research, not getting significant results. And if you get not significant results or results that you couldn't predict on the basis of your theory, you should write that down, and that should get published because it's interesting information. All research results, if the research is done properly, is interesting and worthy of publication, not just the significant stuff. And we should also be more focused on aggregating the results of multiple studies, not focusing on whether one study was significant and the other wasn't, but aggregating that in a meta-analysis, for example. What has changed over the last couple of years, over the last 8 years or so, is that that emphasis has actually been implemented to some degree. And things could still improve a lot from here, but there's been more call for online for more openness, right? So people should make it more easy for other researchers to look at their data, not just the conclusion they've drawn, but at the actual data, because we've seen that even given the same data set, different researchers could end up having different conclusions. So it's important that we can look at that actual data and that data is properly stored. So there has been a lot of progress on that front. So 10 years ago, it was almost impossible to get the data set from a specific researcher, and we now have data sharing protocols that should facilitate that process. What also would help is a pre-registration. So if you wanted to do confirmatory research, and so you're making you want to check the predictions from your theory, that's confirmatory research. Make sure you make those predictions in advance, right? So that's what pre-registration means. You're actually telling people, this is what I'm predicting, this is what my research is going to look like, this is what my analysis is going to look like, and I put that in a virtual envelope, right? I'm sealing it, I'm giving it to you, and now I'm going to do my research, and then I'm going to publish the results. And it would be more convincing to you guys, the readers, because you know for sure that what happened was actually predicted in advance. It was not a case of post hoc storytelling or harking. It was actually predicted on the basis of that theory. Or it's more convincing that it could have been predicted on the basis of the theory because somebody actually did. One way to incentivize this practice is to give people different badges. So if your study was pre-registered, if it used open materials, so everyone could access the materials you used in setting up the research and conducting the research. If your data set is accessible to others, you get 3 badges, right? It's a bit of a gamification of research, you could say it. Right, and of course, statistical significance should not be used as a proxy for quality, and that should be very clear after this lecture, that those two don't necessarily correspond to each other. So the usefulness of the results in theoretical terms doesn't really depend on whether it's significant or not, and or let's say statistical significance is of very limited usefulness in gauging how important a result is, and if we focus on significance too much, it leads to the deterioration of more important aspects of quality of actual research. Beyond that, replication should be central, and you can't get your replication study published because people think, well, it actually doesn't offer anything new, right? And that's an error in thinking, because if you publish something, if you say, hey, I've noticed there were these interesting results, that doesn't necessarily mean that the effect exists, right? You could have made an error, it could have been a fluke, and the best way to check for that is doing direct replications, having the same setup, the same procedure, but a different sample. When people talk about replication, they often mean conceptual replication, which is doing something else entirely with a different group of people, which is still related to the same concepts, but different procedure, different materials, different operationalizations, and different participants as well. So that's not as informative. That's not really informative in trying to filter out the type 1 errors from the publications. There's some relatively new-ish debiasing techniques mentioned in the article as well, so make sure you check those out. We already talked about the devil's advocacy and thinking opposite. But there's some interesting stuff about team of rivals and blind data analysis that I'm sure you'll find interesting to read up on as well in the article itself. All right, so we started this with a quote, right? Being a scientist and a critical thinker in general means that you must not fool yourself. And it's quite difficult to make sure that you're not fooling yourself, right? We ended this lecture with a couple of examples of different biases that you, as a researcher, might encounter. So you need to be on the lookout for that. Am I fooling myself or not? And what can I do to debias myself as a researcher? Then you need to be bending over backward to show how you may be wrong. So you're doing this research, you're making assumptions, and you have to accept the fact that you're fallible, right? So that you're making decisions that could very well be wrong, that you could be fooled by randomness, that you could be making the wrong decision. So you have to be very open about what you did and do everything you can to have others check your results as well. So that's the essence of science, making mistakes in public and for all to see, in the hopes of getting the others to help with the corrections. So that's it for today. We talked about what an ideal science of psychology might have looked like in your head when you were thinking about it before you started your bachelor studies. We talked about what it really looked like and how incentive structures in combination with researcher degrees of freedom might lead to, well, a biased picture of psychological processes in the literature. We've talked about how we can better understand why questionable research practices are indeed questionable. So what the impact of performing those practices is on the type 1 error rate and the type 2 error rate. And we've talked about different biases that you can encounter as an individual researcher and what we can do to debias ourselves and to debias science in general, and thus hopefully working towards a solution for the replication crisis.